So now that we've introduced the periodic table, the different types of elements we may see, including metals and nonmetals, we're going to start building some compounds and molecules from these individual atoms. And we can see here that sometimes there are elemental compounds that form from only one element, such that we have H2 and O2. So certain diatomic molecules noted over here, there are 7 naturally occurring. These will always have 2 atoms together of hydrogen, oxygen, nitrogen. Then there's fluorine, chlorine, bromine, and iodine. So I would remember these 7 naturally occurring diatomic molecules, which again means that there's 2 of the same atom. Then we move over here, we see carbon monoxide and carbon dioxide. And the prefix here tells us that we have only 1 oxygen versus 2 oxygens, and that will be the red atom that we see here. So we'll get into nomenclature later on, but we can see that when we have that 1 black atom, that's the carbon, and then only 1 oxygen, it's called monoxide. And then over here, we have 1 carbon and then 2 oxygens, or a dioxide. These are all molecular compounds. These are all compounds made from all nonmetals. And when we write these chemical formulas, we can see that the subscript, or the small number to the right of the elemental symbol, tells us the number of elements within that compound. So for a water molecule shown here, we have that 1 oxygen, so the O over there, and then the H2 implies that we have these 2 hydrogen atoms bonded to that oxygen. Next, we have hydrogen peroxide. So there's 2 of each, so 2 hydrogens. So we have 1, 2 hydrogens, and then 1, 2 oxygens. So hence the chemical formula, H2O2. Next, we have methane. So methane's chemical formula is CH4, and we see that carbon in the middle, surrounded by 4 hydrogen atoms. And then next door, we have ethylene, which is 2 carbon atoms. We'll see they're doubly bonded, C2 here. And then we have 4 hydrogens coming out in this pattern here. So we can see different arrangements of different atoms will give us different types of compounds here. Specifically, in this case, when there's all nonmetals, we get these molecular compounds. And again, if you locate it above that staircase to the right, those would be all the nonmetals. So again, we saw CO, CO2, NO2, anything that has carbon, nitrogen, oxygen, hydrogen, and the halogens in group 7, those would all be molecular compounds. So we have different ways of organizing molecular compounds here. We can organize them or define them by their empirical formulas. So an empirical formula is the lowest whole number ratio of the number of atoms of each element in a compound. So I have an example over here for glucose. Glucose, the molecular formula, the number of, or the formula that shows us the exact number of atoms of each element is C6H12O6, but in the empirical formula up top here, that's the lowest whole number ratio. So for every 1 carbon, or 6, right, in the molecular formula, we have 12 hydrogens, so that's a 1:2 ratio in our empirical formula. And then there's also a 2:1 ratio of hydrogen to oxygen, so 12:6. So that's where this empirical formula CH2O came from. We just divide the lowest integer into each of the atoms, and then we get that lowest whole number ratio. Lastly, we have here the structural formula, which shows the bonding pattern, which shows the order in which all the atoms are bonded to one another. So we can see with methane down here, we have CH4, so the carbon is in the middle and it's surrounded by 4 hydrogens. So let's see if we can use our skills that we've gained so far. And if we're given the molecular formula for what's called here diborane, and this is the molecular formula here, B2H6, we're asked to give the empirical formula. So just like we did with, or we saw with glucose there, we can divide the lowest integer, so 2, into all the other integers here. So for every 1 boron, right, we would have a ratio of 1. We have 6 or for every 2 borons, we have 6 hydrogens. So for every 1, we would see a 3 ratio here. So BH3 would be the empirical formula for diborane, B2H6.